Hello, everyone, and welcome to our new topic where we dive deep into the use case and future landscape of agents. This is an intelligence briefing designed to transition our thinking from simple digital interns to complex interconnected ecosystems. The core promise we are exploring today is that the workforce is shifting in a fundamental way. We are no longer just deploying static tools to perform individual tasks. Instead, we are hiding digital patterns. This file contains the critical intelligence on where these agents are operating today, the risk hiding in the shadows, and the new world order of tomorrow. Our briefing is divided into three critical segments. First, we will look at section which covers current application in the real world. Next, we'll move to discuss ethical design and the responsibility of the developer. Finally, we will conclude where we explored the multi-agent future. This is a look inside the file marked Eyes Only, designed to give you a comprehensive understanding of the agentic revolution. As we proceed through these pages, we'll see how these systems are reshaping the very fabric of how we work and solve problems in a digital first world. Prepare to see how the intelligence landscape is evolving from a single purpose model into autonomous colleagues. In this section, we examine the evolution of the recruit, focusing on the shift from reactive to proactive systems. Think about the old way of doing things, where we hired digital interns to perform repetitive tasks like watching inboxes or updating spreadsheets. These systems were helpful, but strictly reactive in nature. They needed clearly scoped tasks, like replying to a specific set of emails, and they could not coordinate with other systems unless a human orchestrated every single move. Now look at the new way, where we treat these agents as autonomous colleagues. In advanced team, agents act like true partners rather than just tools. A support agent can resolve edge cases on its own without needing constant guidance. An analytical agent notices spike in refunds and proactively investigates the cause. A research agent proposes new hypotheses based on the data trends it identifies in real time. This represents a significant mental shift from obedient tools and scripts to agentic systems that actually own their goals. The key loop that drives this behavior is sense, then plan, and finally act. This cycle allows the system to operate with a level of independence and foresight that was previously impossible. We are moving from simple large language model application to holistic systems that understand and execute on high level objectives as true colleagues. Welcome to the zone of operation visualized here as the Noir city map. Intelligence notes suggest that organizations are currently building specialized agents tailored to specific workflows rather than trying to create one monolithic AI that does everything. We can divide these operations into four distinct districts. First, we have the frontline, which is the commercial district. In this zone, the behavior is centered on talking to humans. This includes functions like triage support and sales within the service and the retail domains. Second, we move to the lab, where the focus is in reasoning over knowledge. This occurs in R&D or legal document domains where agents perform research and discovery tasks. Third is the engine room, which represents manufacturing and logistics. Here, agents optimize system for supply chains and power grids. Fourth, we have the vault representing DevOps and finance, where agents execute complex workflows and act as co-pilots for operations. Finally, there is the physical world, where robotics agents perform delivery and warehouse tasks. This specialized approach allows for greater reliability and efficiency. By understanding these zones, engineers can design agents that are perfectly tuned to the specific need of their industry, whether they are navigating a legal brief or managing a warehouse floor. Case file number one brings us to the front line of the customer service. This is often the front door for agent adoption because it involves high volume and structured workflows. The agent stack here relies on three pillars. Perception involves reading messages and understanding CRM context and past ticket history. Deliberation involves interpreting the intent of the user and checking company policies. Action involves drafting replies, triggering refunds, and updating internal records. The goal is to create end-to-end support journeys and reduce cost while improving consistency for the brand. Looking toward the 2026 vision, we see three specialized roles. Triage agent also auto-classify and route tickets to the right place. Resolution agents will fully resolve low-risk tasks like password reset or account updates without human intervention. Finally, QA agents will act as internal affairs, reviewing conversation to flag policy violation or quality issues. This comprehensive approach ensures that the customer experience is seamless and efficient. By automating the repetitive element of support, human agents are freed up to handle the most complex and sensitive cases. The result is a more responsive service department that can scale to meet demand without sacrificing quality or accuracy. Case file number two. This one takes us to the lab, where agents act as our junior scientists and partners in discovery. This is not just about the simple data retrieval, it is about synthesis and experimentation. The core capabilities in this zone are vast. Literature reviews involving building citation graphs and tracking conflicting evidence across thousands of papers. Simulation involves proposing experimental setups and determining simulation parameters. Execution involves running code in safe sandboxes to analyze results. Industry evidence from 2025 and 2026 shows significant progress in drug discovery, where agents explore chemical space to propose candidate molecules. In engineering, agents sweep large parameter spaces to discover optimal trade-offs that human might miss. The loop in the lab starts when a user sets a high-level goal. Then the agent gathers data and proposes candidate for the users to review. The agent then runs simulation on those candidates and iterate based on the findings. This collaborative process accelerates the pace of innovation and allows researchers to explore ideas much faster than traditional methods. By acting as a tireless assistant, the agent handles the heavy lifting of data analysis while the human scientists provide the strategic direction and final validation. Case file number three. This one brings us to the engine room, which is the invisible infrastructure keeping the lights on and goods moving through the global supply chain. In this operation zone, agents are critical for resilience and efficiency. For supply chain resilience, agents predict disruptions caused by weather or geopolitics and recommend alternate sourcing for dynamic safety stocks. In the energy grid, agents forecast demand and optimize load balancing for renewable resources like wind and solar. We also see the rise of operation copilots. These agents watch telemetry logs around the clock, raising alerts, and even auto-executing fixes like scaling servers or rotating security keys. The mechanism behind this is a multi-tool agent that can call forecasting models and optimization solvers. Unlike traditional monitoring that just alerts a human when something breaks, these agents are designed to anticipate problems before they occur and take corrective actions. This level of automation is essential for managing the complexity of modern global systems. The engine room is where the physical and digital world intersect, and agentic systems are the grease that keep the gears turning without friction. The end goal is a self-healing infrastructure that can adapt to a change in real time. Case file number 4. This one examines high-stakes operation in regulated industries where mistakes can cost lives or fortunes. In these environments, the design of the agent must be incredibly robust. In healthcare, the status is currently advisory only, meaning humans always have to make the final decision. Agents assist with the treatment planning by analyzing electronic medical records to propose protocols. They also provide diagnostic support by surfacing differential diagnoses for doctors to consider. In finance, the focus is on its speed and compliance. Trading agents monitor markets and execute on signals with millisecond precision, while compliance agents scan for money laundering or identity fraud flags. In manufacturing, the agents are connected to sensors and actuators on the factory floor. They perform predictive maintenance by scheduling repairs before a machine fails and use vision models for quality control to detect defects in real time. These use cases require the highest level of accuracy and security. Because the stakes are so high, these agents are often built with multiple layers of verification and human oversight. We are not just building tools here, we are building systems that we must be reliable enough to handle the most critical functions of our society, from medicine to the global finance market. Now we move into the shadows to discuss ethical pain points. Even the best recruits have a dark side, and agents are no exception. While digital interns can be dream employees, they can also break rules, leak secrets, and act overconfidently if not properly designed. We have identified four major risks that every engineer must address. First is opacity, where an agent might deny a refund but cannot explain why it made that decision. Second is bias, where the agent learns prejudice from historical files and amplifies discrimination. Third is privacy, where an agent might accidentally store secret data in a public log or share it with unauthorized users. Fourth is autonomy, where an agent might take extreme actions like destroying a brand reputation to maximize a simple metric like a click rate. Our goal in this section is responsible agent design. We must acknowledge that these systems are very powerful and can have unintended consequences. By shining a light on these shadows, we can build guardrails that prevent harm. Ethics is not an afterthought in agentic design, it is a foundational requirement. If we want this system to be trusted members of our workforce, we must ensure that they operate with transparency, fairness, and respect for human values and privacy law. The black box represents the problem of opacity and unaccountability. In a broken state, an agent might deny a request based on internal logic that no one understands because the logs are incomplete or redacted. This creates a major challenge for trust and auditing. The design response to this problem is threefold. First, we must have a traceable decision logs. Every single action must be recorded, including the time, the input, the tools used, and the resulting outputs. This is mandatory for high risk environments. Second, we need explainable policies. The policy layer that guides the agent must be human readable, even if the underlying model is not. This allows auditors to exactly see what rules the agent was following. Third, we must establish clear responsibility boundaries. We need a definitive list of which actions are autonomous and which require human control. An important interview takeaway for anyone in this field is to always mention logging audit and explainability when discussing the system design. Accountability means that when things go wrong, we can trace the error back to the source and fix it. We cannot allow our agents to operate in a vacuum where their decisions are beyond questions or understanding. Transparency is only way to ensure long-term success. In this section, we cover the bias trap and privacy leak, which are the two most significant risks in agentic system. Risk number one is bias and fairness. The problem is that training on historical data that often amplifies past discrimination, such as in loan approvals or hiring processes. The fix involves fairness audits to measure disparate impact and maintaining model hygiene by using diverse training sets and strict policy constraints. We must be proactive in searching for bias rather than waiting for it to be reported. Risk number two is privacy and security. The problem here is the over retention of data, unintended sharing, and insecure external calls that expose sensitive information. The fix? It is to implement least privilege access, where agents act like users with specific roles and restricted permissions. We also need technical safeguards like end-to-end encryption and clear transparency regarding user consent. Agents should only have access to the data they absolutely need to perform their task and nothing more. By building these protections into the core of the system, we can ensure that our agents are both fair and secure. Protecting the user and integrity of the data is a primary responsibility for any agentic system engineer or a designer. When agents go off the rails, it is usually due to autonomy without proper oversight. A broken state occurs when a marketing agent is told to maximize conversions and begins spamming customers and violating policies as a result. This is a classic example of why we must be careful and what we wish for and how we define goals. The design response to this risk involves three strategies. First, we must have well specified objectives. Goal must include constraint so the agent is told to maximize one variable while being subject to another set of rules. Second, we need human in the loop triggers. The system should automatically defer to a human when specific risk scores or dollar limits are exceeded. Third, we should implement risk-based autonomy tiers. Low-risk tasks can be fully autonomous, while high-risk tasks should be proposed only requiring a human to sign off before execution. As we look forward a regulatory future, we expect to see more action-centric regulation, focusing on the risk of what agents actually do. Always remember, the interview takeaway is to mention logging audit and explainability. Control is not about limiting the potential of the agent, but about ensuring that its actions remain aligned with the human intent and ethical standard at all times. The new order of intelligence is defined by multi-agent ecosystems. We are moving from single agents to a complex interconnected networks. This shift is driven by the collaboration pattern where different specialized agents they work together to solve a single problem. For example, a research agent gathers knowledge and passes it to a planner agent. The planner agent structures a detailed plan and assigns tasks to an executor agent. The executor agent then interacts with the necessary tools to perform the work. Throughout this process, a watchdog agent monitors the entire system for policy violations and anomalies. The key differentiator here is emergent behavior, which refers to coordination patterns that were not explicitly programmed by the developers. Just as a city function through the interaction of many different people and services, a multi-agent ecosystem achieves complex goals through the specialized contributions of each individual part. This approach is much more resilient and scalable than a single monolithic AI. By breaking down complex problems into smaller tasks handled by specialized agents, we can create systems that are far more capable and reliable. The future of AI is not a single brain, but a society of agents working in harmony to achieve extraordinary results for their human partners. Looking toward the horizon of the next 5 to 10 years, we see a future defined by self-organization. This represents the next major leap in agentic system. Future trend suggests the rise of a self-organizing networks where agents discover each other via centralized registries to dynamically form teams to solve specific problems. We also anticipate self-improving ecosystems, often described using the coral reef analogy. There are complex and resilient systems where meta-agents propose and test improved workflows for the entire community. This leads to a deeper collaboration where the human role shifts significantly. Instead of micromanaging individual tasks, human will focus on designing high-level goal guardrails and governance structures. We will become the architects and governors of these intelligent ecosystems. This shift requires us to think about AI not as a tool we use, but as an environment we manage. The complexity of these systems will grow exponentially, requiring new methods of oversight and control. The goal is to create a symbiotic relationship where humans and agents co-evolve to solve the world's most pressing challenges. This is a future where intelligence is ubiquitous and self-sustaining, providing a platform for unprecedented creativity and problem solving across every domain of human endeavor. As we climb the capability ladder, we must also consider the necessary governance for these systems. The ladder starts at rung 1 with tools using large language models and moves up to the rung 5, which is ecosystem scale coordination. Rung 2 involves single goal directed agents, following by rung 3, where agents operate across multiple tools and environments. Rung 4 is where we see true multi-agent systems. To support this progression, we need a robust governance framework consisting of three pillars. Identity involves providing cryptographic proof of who an agent is to prevent impersonation or fraud. Reputation involves building systems to verify the reliability and past performance of a specific agent. Compliance must be baked into the multi-agent system design, ensuring that all actions align with legal and regulatory requirements from the very beginning. As agents become more autonomous and interconnected, the need for these governance mechanisms becomes extremely critical. We must be able to trust the identity and integrity of the agent we interact with. By establishing these rules of the road, we can foster a safe and a productive environment for agentic innovation. Governance is not a barrier to progress, but a necessary foundation for the widespread adoption and success of these complex debate systems in our daily lives and industries. We have now reached the end of our briefing, and it is time to close the case with a final summary. The big takeaway is that we have bridged the gap from digital interns to complex ecosystem. The future is not just about building better models, it is about designing networks of specialized agents that can work together effectively. For the engineers in the audience, the directive is clear. You must focus on three core areas. Reliability is about ensuring robustness against flaky tools and unpredictable environments. Scalability is about avoiding bottlenecks and allowing systems to grow. Safety is about keeping agents within the operational envelope through strict guardrails and oversight. As the summary notes here, that the skill that defines the future is not just prompting, but designing practical, safe, and governable agent system. We are at the beginning of a major evolution in how intelligence is deployed and managed. By applying the principles we have discussed today, that you can be at the forefront of this transformation. Thank you for your attention during this briefing. The file is now closed, but the work of building the future has just begun. Go out and design the system that will define the next decade of human and agent collaboration and success. Case closed. Good luck on your mission. If you like the video, please do like, share, and subscribe. Thank you.